Okay, let's look at vector embeddings. In the last video, we were discussing about the racks, right? So we need to understand vector embeddings in order to clearly move forward in racks. So first, let's understand what are vectors. Okay, so vectors are nothing but anything that has some magnitude and direction is called a vector. Let's say we have this vector v which has x, y, and z coordinates. So it is telling that move in the x direction, move these many points, or let's say x is 3, move 3 steps forward in x, 4 for y steps forward in y direction, and for z move uh, 5 steps forward in z direction. So that is how we reach the point in a coordinate space. So with vector you have direction, and you know, like in which direction to move, and also you have the like the magnitude or the size, so that you can move that many steps forward in that direction. So let's say if we are doing only walk 5 steps, that means only we have the magnitude or the size. So moving 5 steps, but in which direction? Let's say east, west, north, south. So it should be determined. So that is when vectors came into the picture. We have space and sorry, size and direction. So we need to walk 5 steps north, so here we have direction and also the size. So let's say in weather report we have wind speed of 5 kilometers per hour winds, and which are moving in this direction, moving towards east. So that is a vector. And let's understand vector embeddings in AI space. So let's say a cat sat on a mat. So computers don't understand this meaning, a cat sat on a mat. So how can we make AI models understand this? So we convert each word into token. So a cat is a token, sat is a token, on. So everything is converted into tokens, and um, each token is converted into vector embeddings. So basically, a has some vector embedding, cat has some vector embedding, sat has some vector embedding, on has some vector embedding, and even mat. So everything has some vector embedding, and each number specifies something. Let's say some meaning, some relationship with the other word, and where is it in the, like, the total embedding specifies where it is in the vector space and in which dimension it is in. Like let's say cat, so it is we have a dimension for let's say pet animals. And so cat and dog are closer, and Matt is somewhat far from cat and dog. So that is how we have vectors placed inside the Cartesian, or three, like we can have any dimensions. Like the more the dimensions, the more the accurate, and we can capture the meaning of each word, and I mean the entire sentence as well. So each dimensions captures a meaning. So let's say LLMs compares vectors to find similarity. So we have like cat and dog, and they're very close to each other, and these are like pet animals. Let's say these are for wild animals, and these are like social animals like human beings. So um, if the distance between 2 points is similar, and that means basically they are similar in meaning, or they are closer in one dimension. That is how we arrive at a, like, arrive at a point where 2 point, if 2 points, let's say x and y, they are similar, that means they are similar in meaning. So let's look at, like, if we try to give sentence to an LLM, how does it work? So here each word is converted to vector, that means each word to token, token to a vector. So, but like, how does it understand the words? And also, like, if you give it a sentence, how does it understand the meaning of the sentence? So in before transformers came into picture, we only understood the words meaning, and words were treated independently. We did not understand the context. So let's look at it. So each word is converted to a token or multiple tokens. So why multiple tokens? Let's say unhappy, that means here there are like two tokens. So basically we are converting un to one token and happy to another token, and each has its own vector embedding. So each vector is convert, I mean each token is converted to a vector. So now the model understands only the words. That means we did not understand the complete sentence meaning yet. It only understood the word, and it has placed the words in the space. So let's say we have n dimensional space. So each word is placed in that n dimensional space. And attention is like understanding the context. So each word will look at other words and decide what matters. Like, let's say cat sat on mat, so it did not understand the meaning of the entire sentence. So now it will map with every other word and see what matters, like cat, mat, sat. So these are primary things, and it understands the context over here. And let's say we have bank, river bank versus the deposit in a bank. So this bank is in finance space, and whereas this bank is like just telling the location or place. So riverbank is a place. So each word, but I mean it is same, the words are similar, but it has a different context according to the words before it or after it. So it understand context in this way. So the old AI systems only treated words independently. That means it did not understand the context. Let's say pre AI era, like in 2017 or 2016, when we give it a sentence like a cat sat on a mat, it did not understand the entire context of the complete sentence. It only understood the words. And I think we used to do projects like semantic I mean, no, like if the sentence is positive or negative. And we used to find using the words, like if there is any negative word in it, then we treated the complete sentence as negative. But sometimes it was not negative comment. So how transformers, that is how transformers came into the picture, and we understood the sentence meaning instead of just the word meaning. So let's say a cat sat on a mat, and each has some vector embeddings, and each vector embedding is passed through layers, and in each layer you understand something. And we change the vector values, like inside there are values, right? We change the values accordingly. And let's say a cat sat on a mat, cat is here and mat is here. And we will try to form a relationship between those 2 points and understand the context. So in each layer we find some pattern, and we attach them or change the dimensions or the vector's value. That is how we understand the meaning in a sentence. So what we have discussed until now is like what is like vector and vector embedding and words meaning and sentences meaning. And we also understood about like high level how transformers work in high level. We will discuss about transformers later in other videos, how each layer, what happens in each layer, and how many dimensions should, let's say, LLMs like ChatGPT, how are they choosing, like we have 768 dimensions or some thousands of dimensions, and how dimensions affect or how, how accurate can we get, and how like some models are great at reasoning, and how are they great at reasoning, and some are very intelligent, like Claude is intelligent in doing coding tasks, whereas ChatGPT is better at understanding and giving reasonings. So we'll see how these dimensions help in forming the model, and how, let's say, if we have more dimensions, we need more computes, more GPUs, and it is expensive. And also, if the dimensions are more, we need more time to train the model. So we'll see the trade-offs, how the engineers at these companies are deciding. Yeah, that's for another video. And let's discuss about vector, I mean, so primarily we were discussing about rags, right? So rags has some vector databases, vector DBs. So we'll understand about vector DBs as well, and how these vector embeddings are stored inside the vector DBs, and how we are getting or finding the meanings or similarity search using these vector embeddings, and what are the techniques used in the similarity search. Like there are many techniques, let's learn about all of those techniques, and how we can make our rag models better. Thank you. We'll catch you guys in the next video.